In this chapter, we are going to learn the Python facility or the libraries which facilitates or enable the programmer to write the client server applications. This chapter includes the following the topics. First, we are going to learn about the accessing server contents through HTTP, and also we learn to access the images, I mean downloading the images from the remote sites. Then we use the Python library called urllib to access the web pages and also download the images or the text files, followed by the special library which is available in Python called Beautifulsoap to parse the web pages and also to access the file contents. Finally, we write programs, simple programs to access binary files with the Python library called urllib. In order to have the communication between two processes which are available on the same machine or at different machines, we need an interface, and this interface is called as a socket. And this socket is a logical entity which is an endpoint for communication between two machines or two processes running on same machine or different machines. Thus, the socket provides a way for communication between two running programs, I mean the processes. It provides a bidirectional communications or even conversations. That's why the socket is being used widely in client server applications or the web applications to access the server resources through the client applications. In order to have the communication between the server and the client, we have to create a socket, and there are two types, major socket types. Even there are few more socket types. The widely used socket types are stream sockets and datagram sockets. What is this stream socket? Stream socket is a TCP socket which ensures the reliability of communication. And the second one is a datagram socket, which is a UDP socket, which is unreliable socket connection, does not guarantee of the reliability of communication between the two processes or a client and the server. And we need to understand the second terminology, that is called a port or a port number. A port or a port number is actually a service access point. For example, a process which runs at a server is a service, and in order to access this service, we need to identify that service from the client side, and this port number is a unique number which is assigned for that process within the server. And again, this port number or a port is a communication endpoint which is identified for each of the protocol and the address combination. That means the server address by a special number, 16-bit unsigned number, that is called a port number. So in order to create a socket for a communication between two processes, we need to specify the address as well as the port number. Address in terms of domain name or the IP address in the form of IP version 4 or IP version 6 followed by the port number. It is important to have a set of rules for communication between two machines or the processes, and these rules are framed as a document called a protocol. There are number of documents which are available which describes the rules for different forms of communication within the network or internet. And one such protocol document is called HyperText Transfer Protocol, HTTP. This HTTP is a application layer protocol which has two formats. One is a HTTP request and the HTTP response. HTTP request has got a header followed by the contents that are being supplied from a client to a server. Similarly, the response header is actually contains the response header and the actual contents or the contents of a web page or any resource that is requested in the request of a client. Now let us see how to request a document from a remote site, means server, through this HTTP protocol. We'll take up this example. We try to request a resource, a document from a web server with the domain name, that means the host name, which is specified like this, www.pr4e.org, and the port number is 80, and we want to access a resource. This is the server address and this is the port number, and we are interested in accessing a resource which is a text file. And how to access this? This is a command that we need to send to a server. This is a HTTP request. First parameter is a query string method. There are two methods, one is a get and the post. We are now using a get method, wherein this is not a secure way of sending information. Whatever the information that we send to get is will be appeared on the URL of a browser, or even it can be easily captured by the programs which are running across the or over the internet. The first is a query string method get, and the second parameter is a resource address. So what resource we are going to access? The resource is this romeo.txt, which is available at the server, at the web server, having this address, and this is a fully qualified path or location of this resource. We are going to request to this resource. And third is a type of protocol that we are going to use. We are going to use HTTP. There are other protocols like FTP, file transfer protocol, or telnet, and so on, SMTP, etc. The protocol that we are going to use is HTTP with version 1.0, and then we send a blank line. Then we are going to send blank line. So /r/n and again /r/n creates a blank line. This is a carry is written. Moves to the beginning of the line, then go to the new line. In order to create a blank line, again we have to use this combination. And once we send this command to a web server, the web server will respond with the response. Again, the response, as I said, it contains the header information, which is information about the document that is being sent by the server to the client, followed by a blank line, and then the actual contents or the actual resource. As an example, we will write a simple Python program that makes a connection to a web server, existing web server, and follows the rules of the HTTP protocol to request the resource, and we display the contents of the resource or the resource. In order to write a program to access the resource found at a remote server, there is a built-in support in Python called socket, which makes it very easy to the programmer to make the network connections, and through these connections we can retrieve the data from the remote server. Remember, whenever we create a socket, there is a buffer at the client, and whenever the server is created at the host, there is a buffer, and these two buffers are used to hold the information to be exchanged between client and a server. This program has got two parts. First part is sending a command to a server. This is the first part. And the second part is the receiving the information that is sent by the server upon receiving the client request in the form of HTTP command. First, what we have to do is we have to import the library for this network communication called socket. So socket is a library which is available. And second thing what we have to do is we have to create a socket, the endpoint for communication. Remember, the server is already running, and server has a socket which runs at, for example, a port 80. What we have to do is, as a client program, we have to create a socket so that the client socket can communicate with the server through the server socket. So how do we create a client socket? We use a library socket dot socket. So socket is a method which is associated with the socket library, which takes two parameters. What are these two parameters? So first one is socket.af.inet. So this actually represents the address family of a socket. That means it says what type of the combination of address that is allowed for communication. In this program, we are going to use a pair of values. First one is a host name or domain name, or even we can use a IP address, IP version 4, and the second value is a port number, which is a unsigned integer number. So the af_inet identifies the address family containing two values. First one is the host ID or IP address, followed by second is the port number, which is unsigned integer. And second parameter of this socket method is socket.socketStream. This socket stream represents we are going to create a TCP socket. If we want to create a UDP socket, we have to write sock underscore datagram. So this socket method will take two parameters. First one is a address family, and second one is the type of socket that we are going to create. So ultimately, I have an endpoint for connection, my sock, which is a socket now ready for communication. And now we need to establish the connection between a client and the server through the socket called my sock. So we need to use a method which is associated with the socket called connect. This connect, it takes the pair of values. One is called the host ID or IP address, followed by the port number. What is this? The first parameter is nothing but the address of the server, and second one is the port of the server, port number of the web server. There's a process that is being running at the server. So this mysock.connect will establishes the connection between client and the remote server. So once this preliminary things are done, that means establishing a connection, now we are all set to send the command to a server. And already we have seen the format of the command. So we create a string, cmd is a string, which is a command. So we use a query string method get, and the resource that we are requesting is a text file space, the type of protocol that we are going to use, its version, and blank line. And then we call, because this is a string, we use a method which is associated with the string called encode. This actually encodes the string representation into a byte representation, and this byte representation is sent to a server. The command that is represented in the byte stream in the form of byte stream is sent to a server using a method called send. The send is a very low level method in Python, which is something like a system call that we use in ANSI or Unix C style of network programming. So send will normally sends the information to a server in the form of bytes, maybe 2 bytes or 3 bytes or 5 bytes, etc. So the send method, which is associated with socket, sends this information. So information is nothing but a command to access the resource called romeo.text. And the second portion is how do we collect the information that is received from the server. This is the pictorial representation. As I said, server is already available with the IP address or domain name and with the predefined port 80. What we have to do is we have to create a socket, then we have to connect, and the first stage of this program we have to send the command, and the second phase of the program is receiving. Let us see how to receive this resource. Since the resource has got a number of bytes, what we do is we receive a few bytes, maybe 10 bytes or 20 bytes or 5 bytes at a time, till we encounter the blank. And we have to use this loop, while true, forever loop, and we have to use the method receive, receive, which is associated with the socket with the parameter, that means the size of the data that we are going to receive. We cannot have a 1 kilobyte etc., because we are going to use a trivial method, send and receive, normally used to send a few bytes. So now data has got some bytes. Now you check whether the data length is less than 1, that means all data has been read. If it is, if this data has got some bytes, then you decode the byte representation into actual string representation, and then you print with the end space. And this has to be done till all the data that is being read from the server. And what is this receive actually? Whenever we use this method receive, it actually gets the data from the server buffer. Whatever the server, whenever the server gets the command, it puts all the contents or a portion of contents onto the buffer based on the size of the buffer, and we write a client program to receive these contents from the buffer. Similarly, while sending information from the client to a server, again the client puts the data onto the buffer, the client buffer, and the server reads in terms of the chunk of bytes or the entire buffer. It depends on the nature of method that we use in the program. And once all this data is being read at the client, we need to close the endpoint connection by using this method called close. So this is how we can access the remote the resource through a simple mechanism of having the HTTP protocol as a base for communication. This is a sample uh, response of the server. So this is a HTTP header. From here to here, this is actually the command that we run here, and this is a HTTP header. It says HTTP 1.1 is being used, and it's a error code. It's a code, and it is a OK, represents OK, and the date, what server, and what is the accept range of bytes, what is the length of the data that is being received, and also it specifies what is the content type. So it's the text, plain text, it is just a text. Then we have a one blank line here, followed by the text file. So this is a text file that we have received from the server. This is a HTTP response header, which we are not interested in, and this is the actual the contents that are received from the server. Whatever I explained in the last slide while explaining the program, the different methods that are used in the program, as well as the HTTP response header contents, that is presented here in a descriptive manner. For example, the role of RECV receive method, and the significance of a content type, and the insertion of blank line to differentiate between the HTTP header as well as the actual resource contents. Since this HTTP is widely used in web applications as an application layer protocol for conversation or a communication between two processes over the internet or a network or a World Wide Web, Python has a special library designed to support HTTP protocol for retrieval of small documents as well as the large documents, including binary documents over the web. And that library is called urllib. We will see the application of this library in the subsequent slides. Now let us understand how to use a basic HTTP protocol to access the binary file, that means an image from the remote site. As a second example, to demonstrate the role of HTTP to access the remote resource, we'll try to retrieve an image which is available at the remote site. The reading of image, that means reading and storing an image which is received from the server at a client site, requires 4 different steps or phases while writing the program, Python program. First one is we need to establish the socket connection, and we have to send a HTTP request command. So this is the first stage: creating a socket, establishing a connection, and sending a request command. Then second one is receiving the data that is being sent from the server. We have to store the data that is being received at the client. And third one is we need to remove the headers. As I said, we receive the data that contains headers, blank line, as well as actual content. So we need to remove that header as well as a blank line. That is what we have to do as a third stage. We have to remove the trim of the headers. Then finally, whatever the remaining data that is being found in the string, the string which contains all these accumulated data, received data, in that, excluding the headers and the blank line, remaining data we need to save in the file. That means we need to create one more file in the write mode, and then we have to transfer the contents of a string. So this is the first step. Create we have to import a socket, and we have to import the library time. This is actually optional. If a client runs normally, let us say slow, and the server is too fast, in that case better to give a delay between the send and receive, so that we can get all the data bytes. There is no loss in buffering the data, especially while a server puts the data onto the buffer and the client is slow to read the data, then you have a buffering problem. To avoid that, we can even give a delay to the server, so that server puts the data and in a given interval of time, and then client accesses it. Again, this is optional. This is a host that where the actual resource resides. That is actually an image, and this is a port number of that server process, web server. And we create a socket. Already I have explained this. We create a TCP socket with the address family, domain, and the port, and now we connect. So this is a tuple containing host and the port. So we use the tuple notation. We establish a connection, then we use mysock.send. So here we have used a send all. What is the send all? Send all is a high level method which sends not only 5, 10 bytes, etc. It sends all the contents that are present in the buffer. For example, in this case, all the contents that are present in the client buffer are sent. And what is this B? B represents the binary, whatever the data that we send here. We have not used now .encode. We are specifying whatever this string is a binary. So automatically this string is considered as a binary byte string, and we are sending this command get with all this information. Here we, instead of text file, we mention the JPG image that we want to access. The last stage is you open a file in a write mode, WB. There's a write mode, the binary file, because image file, otherwise it is considered a text file. Give a file name and remove this blank line, 4 characters. That's why position gives the initial position of the blank line. There are 4 characters here. We have to advance them, and whatever the contents from this point after the blank line is assigned to a picture from position 4 till the end of the string, and we write the contents onto the file with the write method. Picture is a string, and we close the file. Now we can see a picture with stuff.jpg found at the current working directory. As I said, content type in the header is image bar JPG, and once the completion of the program, we can open the image file and we can see that image, and we can also slow down our the receipt of bytes by calling the method called time.sleep. I have commented in that program, you can uncomment it, and that's why we have imported this time. Okay, and this is important when the server and the clients are running at different speeds, to slow down mm, the server or a client for a milliseconds or nanoseconds. We can use this method, a sleep, so that we don't lose any chunks of bytes or even a byte or the number of bytes while buffering the contents at the server side. That's what we call it as a flow control in the computer networks. In the previous slides, so far we wrote a low-level network program in Python, wherein we supplied the nature of address as well as the port number, and we created a socket, then established a connection, then we used send all, receive methods. So we used a manual send and receive of data bytes. We specified the number of bytes to be sent and received, etc., etc. And we found the length of a program is little large, maybe in terms of 10 to 15 lines while reading an image. This Python has got a special library which wherein we can reduce the length of the code, and we don't have to worry about the network related the terminology and the low level methods to access the resource. And this special library is called urllib. Using urllib, we can treat a web page as a file, and we have to supply the file, that the web page that we want to access, and we retrieve the contents through urllib, and urllib handles these headers, blank line, etc., and it gives us only the requested resource. Here is the equivalent code in urllib to get the contents of romeo.txt file. What we have to do is we have to import this library urllib.request. So we are sending a request, so we have to use this request library of urllib, and then we have to use a method called url open, url library dot request dot url open, and we specify the name of the resource, fully qualified name. We don't have to specify the address and the port number and what type of protocol. We don't have to mention. URL library takes care all of these things, and this actually URL open will return the actual resource contents present at the remote site with the name romeo.txt. This is a remote site and this is actually the resource at a remote site. And now these contents are now available in HIND. HIND is actually the file handle. As I said, it actually treats the web page as a file. So we get a file containing all this data, and we read the data line by line. The same time we decode, because it is a byte stream. Byte stream, the file is in a binary mode. You do decode, we get the uh, string representation or text representation, as well as you can chop off the white spaces that are found in the beginning and the end of each of the line. This is how we can read a resource, a text file, with only 4 lines of code. As I said, once this web page has been opened using URL open, it just reads the contents and returns the data in the form of file, and actually it's a pointer to a buffer, and then you can read the buffer contents much like a file. And also we don't have to worry about the headers and blank line, etc. URL library code consumes all these headers and then returns only data to us for the processing. Let us take up the second program. We'll modify this program to compute the frequency of each word present in that text file. The same concept. We use a request method. Okay, and this is for any if we are using any parser you can use, and if you want to display any error while processing the web page, you can use this library. These two are optional. One thing is, this is important, URL library request, and open the resource. Now we have a file handler fand, which contains the file contents, and we create a dictionary, empty dictionary, and for each in the file handle we decode the line, convert the byte representation to text representation, and split the line based on the white spaces. Now we have a list of words, and for each word we put into the dictionary based on its presence. If it is present, you increment the count, a dictionary value. If it is a new word, insert into it with the value 0. Already these things have been explained in the chapter dictionary. Finally, we can print the count of all these words and these words, as well as is the frequency. So here we are going to print the entire dictionary. This is the second example where we read a text file and you print the frequency of each of the word present in the text file. The most common application of the URL library in Python is to extract the information from the web pages. That is what we call web scraping. Web scraping is a program which retrieves the pages, examines the data in those pages and look for the patterns and extract the interesting patterns or the specific patterns for further processing. If we see the Google search engine, what it does is it starts from one page that is called as a source, and it finds all the links from that page to other pages, and it goes to those links, extract those pages and links in those pages, and this process is continued to extract all the pages. That's how search engine gets the huge list of web page links, and this extraction of links and the subsequent navigation through the links is done by the spiders, and Google has got a spider which goes through all the pages on the web to get the relevant and interesting links. And Google also uses the frequency of links as a measure to give a priority to the discovered the web pages, and this is a measure of how important a page is, and it depends on the number of the links that are incoming to a web page. If more number of links are incoming to a page, then that page is more likely to be retrieved, and this concept is being used to prioritize the search results. As I said, urllib library is used to extract the useful information from the web pages, and the one way to extract the useful information from a web page, that is to parse the HTML, is use a regular expression repeatedly to search and to extract the interesting strings or substrings or a specific pattern in the web page or HTML segments. Let us consider a simple web page as an example, and for example, let us say we want to extract the link like this: http www and so on. How do we extract such links from a web page? What we have to write is, we have to write a regular expression to match the href equal. Then we have to match for this, followed by the characters. And once we have a regular expression, and we can use the find all method of a regular expression to extract all the links, such links, by using the regular expression, the characters to recognize and to extract the useful and interesting information. This is what we have to do. We need to construct the well-formed regular expression for a given match, so that we can extract the all the hyperlinks that are present in the. This is the regular expression href equal double quotes, and it should start with http after double quotes colon double colon, then dot is for the match of any character, one or more, and also we find a question mark. This question mark indicates match to be done in a non-greedy fashion. What do you mean by non-greedy fashion? It tries to find the smallest possible match. The greedy fashion always, greedy match always tries to find the largest possible match, a string. So we are now interested in a smallest match, possible match. That's why we use this the character, regular expression character, to have a non-greedy match. And finally we can have a parenthesis here after the double quotes and here, so that we can extract the hyperlink by excluding href equal and double quotes. Let us see the simple program. What we have to do is we have to use this library urllib.request, and we have to import this regular expression and use a input method to read a website or web page address from the user. It gives the URL, and now you send that URL to the URL open, and you read the contents with the read method. So read method will read the all the contents at this URL, and now HTML is a huge string. So remember, here we are reading all the contents with the read method. We are not using any for statement to read the contents line by line. We are reading entire web page with the read. And now HTML is a string containing the web page contents, and apply this regular expression re.findAll on this string HTML. And now we have to do a pattern matching on binary. That's why this B need to be present. It's a binary data that we get. B binary, href equal, and we use a parenthesis to extract only the links. And this gives me a list of links, array of a list of links, and for each link you try to display the link by decoding the binary representation so that we get the textual representation. This is how we can extract all the links that are present in a given web page. For example, if you supply www.gmail.com, you will find 3-4 links. If you supply www.kendraengineering.in, you will find 7-8 links. Similarly, if you try with other links, definitely you will find more links that are present in the given web page. There are number of libraries present in Python to parse the HTML pages and to extract the relevant data or useful information from these pages for processing or for the analytics. And each of these libraries have their own strengths and limitations, and the programmer need to pick the most suitable one for the application based on the requirements of that application. And one such simple library available in Python for parsing and to extract data is called Beautifulsoap library. This parses both HTML as well as XML. And XML is follows a strict syntax, and wherein HTML does not follow a strict syntax. For example, in HTML, if you have a open element, for example paragraph, and you don't have to close that paragraph element. But in case of a XML, if we have some opening element, we have to close the element. Otherwise, the XML parser will reject the entire document. But in case of Beautifulsoap, we don't have to worry about the flaws that are present in HTML. The Beautifulsoap will tolerate even the highly flawed HTML, and still you are able to extract the data that is present in the web page. Let us take up the first example of using this BeautifulSoup library to read the page and to extract the links, that is attributes of href. Href is the attribute, the values of href attribute. One thing we have to remember is BeautifulSoup uses the urllib library. That's why we need to import urllib request. We need to use a parse because it uses a urllib built-in parser, and even the library of the errors, urllib.error. And then we have to import the BeautifulSoup from the folder. So this is a folder. Let us say we have kept this library in a folder within the working directory. Then you have to write from the folder bs4 import the library bs4. Then we have to use this secure socket layer library. This is required as the BeautifulSoup uses this library for secure communication purpose. First, we have to ignore all these security related data that has to be supplied for BeautifulSoup. First, we have to create the context by using the SSL create default context CTX. This is a security context. Then you have to make a false, check host name. We don't have to check the host name for the authentication. Similarly, we are not interested in verifying the digital certificates. So the context.verify mode certification, none. We are not sending in certificates to the server for authentication. Once these things are disabled, all these security SSL, secure socket layer related certification things are disabled. Now we have to make the user to enter the URL, for example www.gmail.com. Then open this web page with the urllib request.url open URL, the security context. So this is CTX object we have created here, where we are ignoring all these security related information. Then we read. So now HTML is a string containing the entire web page contents. Only the difference of previous program and this program is we have a context. There is a security context equal to CTX. Then we use a BeautifulSoup library on the HTML, and we are going to use a parser. There is a HTML parser. If you want to parse XML, then it is XML.parser. Since the data there is a HTML in nature, we use a HTML parser. So this is a string containing HTML, and the second is the nature of parser that we are going to use. And now SOAP is a object which contains all the useful information of a given web page. Now we can access the relevant information that we are interested in by referring this object. Here it is SOUP object. First, as we are interested in to retrieve the hyperlinks, all these hyperlinks are found in the anchor tags, that is tag A in HTML. So try to get a list of all such anchor tags. Use object SOAP of A. It gives a list of all the tags, elements containing all these attributes, everything, starting from the starting element A until the end element A. And for each tags in the anchor tag list, what we have to do is we have to get the attribute tag.get. Which attribute? href. If that attribute is not present, then you return none. Otherwise, this get will return the value. If there is no value, then it returns null. This is how we can access all the attributes, hyperlinks present in a web page. For example, if you want to get all the images with the source, what you have to do is, here you have to write img image tag, then all the imgs tag dot get src source. You will get all the image links that are present in a web page. This is a second example that we can see to pull all the various pull out all the parts, different parts of each tag present in the web page. Same thing, we have to import Beautifulsoap URL library, ignore the security context, then read the HTML contents using URL open, then use the Beautifulsoap with the help of HTML parser, get the object, and now you get the anchor tag, all the anchor tag, list of anchor tags. For all these, for each of the tags, anchor tag, try to get the href, get the content of the description of the anchor tag, a hyperlink, then we have actually a description of that tag that is obtained with the contents of 0, then all other any other attributes that are present that you can retrieve from this tag dot attributes method. So this is all, this represents all the contents, and this is href. Just get the tag dot get retrieves the value of attribute href. This gives the all the attributes present in the tag. This is how we can display the anchor tag, its hyperlink value, and all other remaining tags, attributes like on click, one attribute, or a style attribute, all the attributes that you can list here. Let us take up the third example to pull the links of all flower images from an online flower store. As I said, here we have to concentrate on img tag of HTML, and then we extract the value of source attribute. So this is a program. This is already explained to you. This is a security context, and the URL is, let us say this is the online flower store URL, and you read the front page of the flower store by using a method URL open URL context and read, then parse the HTML page using HTML parser with the help of Beautifulsoap. Then now we are interested in only image tag. Okay, we are interested in image tag, and open one text file on write mode so that you can display all the links, image links, and for each of these image tags in the tags list, try to write that tag value onto the file. Okay, write the actual the tag, and then you write the actual the source, the tag dot get href, the actual source, and then you can write even other attributes that are associated with the tag called image img. So with this you can get all the hyperlinks or the link source links of images. We can also read the non-text files, the binary files such as image, audio and video files easily with the help of urllib. What we have to do is we have to read the entire contents of the document into a string variable and then we have to give an appropriate name to a file that is stored locally at the client place. Let us say we want to access an image from the remote site. We have to use this library, import url library.request, and open the site resource cover3.jpg and read all the contents and put in a string. In the meantime, open a file on the write mode. Since the file is a binary, open it in write wb and put the contents onto the contents of the string image onto the file with the write method. Then you close the file, and now you can see that cover3.jpg that is found at the working the directory. And what you saw is the previous program. It reads all the data at once across the networks and stores it in a variable img and in the main memory, and then we transfer the contents of main memory onto the secondary storage by opening a file and then writing the contents of img string onto the file and then closing a file which actually transfer the contents back to the secondary storage. However, if the file is too large, in case of the video file, then above program may crash or might take more time because of the limitation of processing in the computer because of the low size, maybe a small size a RAM or a main memory. In that case, in order to avoid running out of memory, we can retrieve the data in terms of blocks. We don't have to read entire content. We can read the file content in terms of chunks of bytes, and then we can store them, and then we can transfer onto the secondary store. This way, a program can read any size file without any problems of performance in terms of the uh, the termination of the program, or in terms of poor execution speed or response. Here is a program, a same program. We can, instead of reading the entire contents of the JPG, what we are doing is we are reading 1 lakh bytes at a time, and then we are writing onto the file instead of reading entire file. This is actually helpful. This code is helpful when we have a huge audio file or a video file. Also helpful if you have a image file of a high resolution, which is of 50 MB, or image of size 1 GB. In that case, better to open the file using URL open that cover3, and then open the destination file in the secondary in the write mode, and you read maybe 5000 bytes at a time or 1 lakh bytes or whichever, based on the capability of your main memory. You can read the number of bytes and you can transfer directly onto the secondary file, and finally you can close the file to reflect all the changes in the secondary storage. So this is another example to extract a flower from a website, maybe online flower shop. We open the image using urllib url open method. So this is a huge path, fully qualified path of that image, and we read the entire the contents of the image, and we put it onto the file that is being created for writing. So this is how you can read one image at a time from the website. For example, If you want to read all the flowers that are present in the online flower shop, how to do, how to extract all these, download all these flowers. There are two stages. First stage is you have to use a Beautifulsoap to extract all the img tags and its links, source link, that is href. So extract these href values and then use a urllib to open each of this, all this list of urls, and create a separate file by giving flower 1, flower 2, flower 3, or even you can retain that original name also by using a split function. Whatever method you can, with that method, uh, with this procedure, you can download all the flowers or images that are present in a web page. Remember, it's a two-phase step procedure. First is extracting all the image links using Beautifulsoap, then use a urllib repeatedly for all these links using a for statement, and create a number of files for each of the links and store these images. This is how you can extract, you can download all the images that are present in the website. So this is one exercise that you can take up to download all the images present in an online flower shop. These are the few review questions for self assessment. Go through these questions and try to find a suitable answers. And also I request all the students to execute all those programs which are present in the video, to execute and to debug, and also modify those experiments for more type of problems. For example, downloading all the images, downloading all the lists elements in the HTML, download in the sense extraction. Similarly, extraction of the span elements or headings, all that you can manipulate these programs, and you can try with the different the can try on different HTML element tags to extract the relevant information.